Studies show. 2 words, and suddenly the argument is over. You are not disagreeing with the person anymore. You are disagreeing with science. That is why the phrase is so powerful. It sounds like someone already checked. Like the question is closed. Like your doubt is the problem. But here's what nobody tells you. Studies can be real. The numbers can be real. The university can be real. And yet the conclusion everyone repeats can still be wrong. Because science almost never said what the headline claimed, or what the podcast host remembered, or what the self-help book turned into a rule for living. Usually, science says something smaller, more cautious, and a lot more limited. Then culture does what culture does. A correlation becomes a cause, a percentage becomes a panic, a sample becomes humanity, one study becomes settled truth. Not because someone faked data, because the claim got too confident. That is how real science turned into fake certainty. And once you see the pattern, you start hearing studies show very differently. So here's how it works. You probably think bad science spreads when people reject evidence. You notice that study that confirms your diet, your parenting, your politics, your habits, and you quietly explain away the one that threatens them. But that is only the obvious version. The stranger version is that bad science also spreads through trust. Not because you hate science, because you respect it. You hear studies show, and the claim arrives with borrowed authority. With borrowed authority, I mean the confidence that comes from science, even when the claim is no longer matching the study. That is where the distortion begins. A paper gives you a narrow finding, and culture wants a big lesson. So the finding gets stretched, it becomes advice, then a rule, then common sense. And once that happens, nobody asks the boring question that would have stopped the whole thing. What did the study actually show? Not what the headline said, not what the podcast host remembered, not what the self-help book needed it to mean. What did the study actually show? Because most bad science content does not begin with a fake study. It begins with a real study that got promoted beyond its evidence. So let's go through the 4 ways that usually happens. And the last one is the one that frustrates me the most. The first distortion is the classic one you have probably heard before. Correlation is not causation, but it is a little more subtle than that. A correlation means 2 things move together, like swimming and ice cream sales, both rising in summer. A causation means one thing actually produces the other, and these 2 are very different claims, and people slide between them without noticing so very often. So here's a real example. In 2011, researchers pulled data from 21 long-term studies and found something clear. If you have insomnia, you are much more likely to develop depression later compared to someone who sleeps fine. So the headline almost writes itself. Bad sleep causes depression. Fix your sleep, fix your mood. But the study does not prove that story by itself. Insomnia can predict depression without being the simple root cause of depression. 3 stories can sit inside the very same finding. Maybe insomnia helps cause depression. Maybe it is an early warning sign of depression already developing. Trouble sleeping is also one symptom clinicians look for when diagnosing depression. Or maybe stress, grief, financial pressure, or family conflict produces both. Same finding, different story. And each story points to a different solution. Prevention, early treatment, or changing the conditions around the person. That is the trick. Simple as that. The study says this predicts that. Culture hears this explains or even causes that. And once explanation enters the story, the advice arrives immediately. Fix your sleep hygiene, get off your phone at night, just relax a little more. But if you do not know what the finding actually explains, you may spend years treating a signal like it is the source. So the first question every time someone says studies show is this. Did the study explain what caused the problem? Or did it show that 2 things tend to show up together and someone else turned that into an explanation? Because a real pattern is not the same as knowing what is steering. And that is before you even ask how big the effect actually is, which is where the story gets even worse. The second distortion happens when a real number sounds bigger than it actually is. A number can be completely true and still mislead you. It sounds absolutely ridiculous, so let me show you in a real example. In 2015, the World Health Organization classified processed meat as carcinogenic to humans. Carcinogenic means it can cause cancer. So the headlines wrote themselves. Bacon causes cancer. Processed meat sits in the same category as tobacco. Your breakfast is trying to kill you. And look, the finding is real. And the risk is real. But the category does not tell you how big the danger is. Processed meat and tobacco can sit in the exact same evidence category while producing wildly different amounts of actual harm. You hear same category and your brain quietly translates it into same danger. And that's not what the category means. Then comes the number itself. Researchers linked eating 50 grams of processed meat a day to about an 18% increase in colorectal cancer risk. 18%. That sounds huge, but it's a relative number. Here's what that actually looks like. If your lifetime risk of colorectal cancer is about 5 in 100, then an 18% relative increase moves it up to roughly 6 in 100. That 1 in 100 jump is the absolute number, the actual real world change, and a lot less dramatic than 18% higher risk. For comparison, the CDC says smokers are 15 to 30 times more likely to get lung cancer or die from lung cancer than people who do not smoke. Same broad idea, evidence that something causes cancer. Very different scale of danger. And this is where headlines get their power. Relative numbers travel because they sound dramatic, and absolute numbers slow the study down. And nobody clicks on small but real increase, depending on your baseline risk and your diet overall. So you get the simple version. Bacon causes cancer. Technically connected to the evidence, emotionally far beyond it. So the second question is, how big is the effect in real terms? Not whether there is a number, not whether the number sounds scary. What actually changes in your life? Because a real effect can still be smaller than the fear it creates. And that fear travels a lot further than the study ever did. Which raises an uncomfortable question. Whose life was that finding even about? The third distortion happens when a sample quietly turns into all of humanity. A sample is just the actual group the researchers studied, and every sample has limits. Age, country, income, culture, education, health. Specific people who happen to end up in the very rooms to do those tests. But those limits tend to disappear by the time the finding reaches you. A study of American college students becomes all people are like this. A study of Western teenagers becomes adolescents are like that. And a study of middle-class families becomes children are like this. That jump feels small, but it really isn't. Psychology does not study humanity from the sky. It studies specific people in specific contexts, doing specific tasks under specific conditions. Sometimes that result travels well to everyone else. Sometimes it does not. And you do not know which until someone actually checks. Here is a study you have probably heard the headline of. Researchers put a marshmallow in front of a 4-year-old and gave them a choice. Eat it now or wait a few minutes alone in the room and get 2 instead. The famous version says, the kids who waited grew up more successful. The story is simple, memorable, and perfect for a parenting book. But the original kids came from a very small preschool connected to Stanford. Useful? Well, yeah. But a universal law of childhood? Absolutely not. And when later researchers looked again with a larger and more diverse group of children, the famous story changed. The effect did not simply disappear, but it became much smaller once family background, early ability, and home environment entered the picture. I'll probably do a whole nother video about the marshmallow thing, because it really deserves its own case study. For now, here's just a smaller point. A study can only speak clearly about the people it actually studied. Everything beyond that needs its own evidence, and nobody tells you where the limit was. So the third question is, who did they actually study? Because studies show sounds like it's talking about everyone, but it really never is. Which brings us to the distortion that annoys me the most. Because it is not about misreading one study, it is about what happens when nobody ever goes back and checks it twice. The fourth distortion happens when one study turns into the end of the conversation. You probably remember power posing. Stand like this, take up space, hold the pose for 2 minutes, and your body supposedly changes your mind. More confidence, more power, and even different hormone levels. It was the perfect self-help science. Simple, visual, empowering, and easy to do on a stage. And there was real research behind it. That is exactly why it spread. But then, other researchers tried to reproduce the stronger claims. A larger replication tested them with more participants and more rigor. It found no effect on hormones, no effect on actual risk-taking. That distinction matters. Feeling more powerful is one claim. Changing your hormones and your behavior is a much bigger one. But by the time the careful, boring version showed up, the exciting version had already gone viral. Someone might ask, were the original researchers frauds? No, that's too easy. The more uncomfortable lesson is this. One study should never have become a life philosophy in the first place. So the fourth question is, did anyone find it ever again? Replication means other researchers test whether a finding shows up in a second time with different people. And meta-analysis means researchers combine many studies to see the overall pattern once the noise cancels out. Neither one gives you a magic certainty, but both protect you from falling for the first clean story that happens to sound good. And the first clean story is always the one that travels fastest, long before anyone has had the chance to check it. So next time someone says studies show, do not just reject the study. Ask better questions. Did the study explain a cause, or did it show that two things show up together? If two things move together, you still do not know why. How big is the effect in real terms? A result can be statistically significant and still barely matter in your actual life. Statistically real just means the pattern probably did not happen by random, not by chance. It does not mean the pattern is big enough to change anything. Who did they actually study? A finding about one group does not automatically describe everyone else, no matter how confidently it gets repeated. Did anyone ever find it again? One study is not a conclusion. It is a starting point everyone forgot to finish. These questions will not make you instantly right. They will not replace expertise. They just slow fake certainty down long enough for you to see it. Because the real danger was never only that you might believe something false. It is that you believe something oversimplified, with the full confidence of science standing behind it. That confidence is powerful, and it is usually borrowed from somewhere it was never actually earned. Which is exactly the deeper problem here. Science does not remove interpretation. It disciplines interpretation. A study gives you a method, a sample, a result, and a list of limits. Culture wants a lesson, a villain, a hero, or some simple rules to live. The distortion happens in exactly that translation. The paper might say, here's what we found under these specific conditions. The headline says, here is what this means for your life. The podcast says, this changes everything. And the self-help book says, do this every single day. And by the time the idea reaches you, the limits have quietly disappeared. So you're not just hearing science. You're hearing science after it has passed through incentives. Attention, publishing, content, status. Every step rewards certainty. The researcher wants attention. The journalist needs a headline. The creator needs retention. And the audience wants clarity. And the finding gets simpler at every step. Not always because someone lied, usually because complexity is expensive and certainty is cheap. That is why studies show should make you curious, not obedient. So the next time someone says studies show, including me, do not stop listening. Start asking, what kind of study was it? How big was the effect really? Who did they actually study? Did anyone ever find it again? And what did the study actually show before someone turned it into a lesson? Because science was never the sentence studies show. Science is everything that sentence leaves out. The method, the sample, the uncertainty, the limits, the argument underneath, all of that together. And most of us are not actually following science. We're following whoever explains it with the most confidence. Make sure that they earned it.